Hey, your friendly DevOps admin David from Trivial Solutions IO here. And today I'll talk about things that I think every startup needs, and it's databases. And why not Postgres? And it's my favorite database. I have second favorite SQLite, but it's not like SQLite is more like application level. This is like on a web server serving web requests. And why I want to talk about this, because today, like, if you visit CNCF landscape or like what's new stuff, you read blogs in the industry, you have like a gazillion choice of a database. So if someone's that doesn't know any better and just comes out of a university, or they simply don't have experience, they don't know the implications, so they might have a trouble picking which one they would need, right, to satisfy their business requirements. And here I'll just try to say, long story short, this video will be about how Postgres can cover like pretty much a lot of ground that you need for a startup, for a typical database, right? So you might not need to use something new, something you don't understand. You might use something that stood the test of time, that's been there for decades, right? That's been scaled for 20 years, like performance improvements, features, and whatnot. Most advanced open source database, Postgres. And so why would I want to, for instance, pick Postgres? So I will not mention any names, not to, like offend people's feelings that use like some more exotic one of these new databases. But I don't want to use untested technology in production, right? Because typically, if you have application, debugging application is hard enough. And if you use like a new database, then of course, if it's only been around a few years, there's a lot of chance that you might come across an edge case, some bugs, you might spend time like debugging components that you don't control. So if I know that I pick something that's been there in production for multiple decades, then I know I avoid a lot of pain and heartache. So there's this like saying, the prevention is cheaper than the cure, and the same applies here. Usually, people might invest a lot of time spending, like writing all sorts of sophisticated analysis tools, and it's all that. But sometimes these decisions can simply be made very early to use A or B, and if you pick B, you just avoid a lot of trouble down the line, and you don't deal with it at all. You don't need to put additional complexity into your processes and whatnot. So, and another thing, why this is beneficial. So if you master one component really well, like Postgres, and if it covers a lot of ground, so then your knowledge becomes like quadratic. So you don't need to trail every new thing that's in the industry, learn it, read books about it, courses and whatnot. If you know one thing that's like covers a lot of ground, you can master that one thing and just, you'll satisfy a lot of needs for your clients just like that, like from the first time, and you don't need to learn tons of stuff, So that's another great benefit, that, your knowledge becomes really valuable, because you might have, more specific knowledge about this thing and it's more concentrated, but it provides more value. So, you don't need to then hire, say like Elasticsearch guy, like MongoDB guy, like ScyllaDB guy, 3 separate guys to run 3 separate databases, when you can simply hire like a Postgres guy, and then you cover a lot of ground. And I'll talk about what we'll cover right now. So the common questions about Postgres: is it highly available? And you can make Postgres highly available. I, for instance, now prefer to use Patroni in production. It makes your Postgres instances, you can spin up one master and a few replicas.
then if one stops syncing, then it switchover happens to another, or you can perform switchover manually, and your database just keeps on running if one node is down. So this a lot of these new databases boast that, we're highly available, we're horizontally sharded. You can have that with Postgres also. And another question that a lot of people ask, and they say, oh, well, will it scale? So first of all, I will just mention that I wouldn't worry about scaling unless you have lots of users already. And typically in a startup, you're starting off, you might not have a lot of users, so you can pick something that, scales really well on one node, and then once you're complete your startup idea with tested technology, you spend all this time delivering just features with what you already know, you save all this time, then you might need to do something about scaling. And another thing, if you're at a small scale, people view this, we're at a small scale, then, where it's like something to be ashamed about. I would be happy to remain in small scale, because in a small scale, things are simpler. It only gets worse once you get more users. So if your business model is say something crypto trading, arbitrages and whatnot, you don't need that much infrastructure, right? So if you have this business model that doesn't require this infrastructure, but you produce millions from that, and you have only a few servers, then that's cool. As opposed to a business model where you need to have a gazillion of users, and from every user, if you take a penny or two, then and you happen them it's efficient enough, and you spend bazillions on marketing, so they would bring those pennies to you. Well, then you have a lot of risk and you have a lot more challenge. But I'm not saying change your business model, but I'm just saying small scale is not to be ashamed about. And if you can start at small scale, consider it advantage, not something to be ashamed about. And of course, we'll talk about scaling Postgres because it has its own tips and tricks on how to do that. And some people, start using Postgres, then, our queries are slow, and they typically don't have experience with databases. So then you can start asking questions. Okay, did you try adding indexes? So index on a database is like index on a book. At the end of the book, you have alphabetical terms, and then you can look up the page where that's mentioned. And index is exactly like that. So, you can index by any columns you want in Postgres. If some query is slow, then you need to analyze the query, why it's returning slow. It's probably doing sequential scan over your entire table. So then you add index, and usually those queries become quick. That's very simple trick. And another thing is, do you give it enough memory? Because, for instance, Postgres, if you run it by default mode, it uses very minimal memory because it's on your development machine, so that, you can start developing with Postgres, but it might not be ideal production setup. Of course, good DBA should know this, you need to provide sufficient buffers, like say half of the RAM of the machine or more, just a rule of thumb. You can do that. And of course, queries should be a lot quicker if your data is cached in RAM entirely. And another thing, on log tables. So there are sometimes a user session, if you store it in a table, if it disappears and database restarts, user might need to log in again. If it's not a big issue, then you can create table with unlogged statement in Postgres. It's then not written to write ahead log. If database is restarted, your table is truncated, so it then becomes a lot faster. I remember some blog post, it was 90,000 inserts per second, something like that. Crazy number, So that's another thing. Unlock tables, you can do that. And again, did you try partitioning? So if, for instance, a query, say analytical query, and you need to find records from say a certain month of the year, you can partition table in a month So then database doesn't have to search through the entire data that you have throughout all your tables. So say you have like 1,000,000,000 records and they're split by month. If you have partitioning, Postgres native partitioning, you can configure that. So you might need to scan only a small portion of that table. So that's like another performance improvement that you can do if your queries are slow. And another thing, did you try sharding? You know, if say you can start with one shard and then you have a lot of tables, many different tables, and you know, eventually you see, oh, you know, like I try all these tricks and then my queries just start to return slow. Data doesn't appear to fit on RAM. Okay, another trick you can do is have two databases. Say like you separate one table that is like really hammered hard, right? So you split those into two shards and you query those databases separately. And that's another trick that you can do to scale Postgres instances, right? So, and another, did you try like querying a read-only replica, right? So with Patroni, you run highly available like 3 nodes, you can only query a read-only replica if your query is read-only, because a lot of times workloads are like you do a few inserts, few updates, but you do a lot of selects, read queries, so you can direct that to read-only replicas. Or you can, it's not like, this is like full replica that Patroni does, but you can do a logical replica, and you can use logical replication. You can create another Postgres instance connected to the primary instance or replica instance, then say, subscribe to these tables and bring them copies to me. So like a database is like, you know, this is a replica or a full shard, and then you can have a small logical replica that might receive like only, this say has like 20 tables, and this say has only 2 tables, logical replica, and then on a separate instance you can hammer this hard and not affect primary at all. So as you can see, there are a lot of things that you can do to scale Postgres, and these are simple setups like one instance with Patroni. This is like a standard stuff, but there's also a scaling super weapon. This is like a Cetus Postgres extension, right? So you can make it that one table would be horizontally sharded across many replicas. And every single replica has like a part of the same table, different records. And then when you query those, you get results from all of them. So they do all scans in parallel, right? So you can scale Postgres like horizontally like that. You can have, you know, 16 nodes working together, you know, 32 nodes working together. So this is like of course, this is hardest setup to run, but ideally, if you want to like save your time, don't start with the most complex setup. You know, start with one and start adding like smaller things, simpler things that work. And then once you find that smaller things don't work, then you go to more complex things and you try other and other things, right? So this is about scaling. So you can scale Postgres, you know, pretty well, right? So of course, if you're like a Google or Facebook, then you know they use like custom solutions and whatnot, right? So they will be super complex. But for most people, you know, this should suffice most of the startups today, right? So why would you use something more complex, possibly untested, possibly full of bugs, when you can like try this with a single database? And you know, if you can stay here, then you have a very simple life and you're very productive, you're very nimble, you know, you're very quick, right? So you can have a lot of mileage from this. And I'm just talking about scaling. And I'll talk about another feature of Postgres, like for instance, you can create queues on Postgres. So there's this PG notify. So like a client can listen to Postgres connection and can have real-time notifications. So when user like insert something or update some table, you can get instant notification in a client and take appropriate action. So you can implement queues if you want. Well, for queues, I personally like nets, but it's not that I'm not satisfied with PG Notify implementation. But there are a lot. This like is a newer thing. Queues in Postgres. So not all of the database clients support PG Notify. So that's like the only reason. You can get a lot of mileage from queuing in Postgres. You know, if your client supports PG Notify well enough, real-time notification. So you can even replace queues at the start if you want. And another thing why people flock to these new key value stores, right? This is schemaless data. You know, key value store, you have key, and then you usually have like key value pairs in a record. So you can simply have this with Postgres. You know, you have a table, key and value columns, right? You index the key column so that you can search by it, and then value column is JSON B. And JSON B can have any schema you want. You can store JSON, so you can store anything. Well, I always prefer storing my data in a structured way in a tables, so that I know, if a query doesn't work, analyzer fails, I know that somewhere my data is bad. If you can store as JSON B, you can store pretty much anything. And then if a query sometimes returns funny results, it doesn't fail because data is different. You have earlier version than later version because you don't have like consistent data with this. I prefer structured data, but I'm saying people who go to these like document storages, I won't mention names. You can have the same thing if you want with one table, key and value with JSON B, and you have the same thing essentially. So yeah, and another feature is full text search. There are a lot of like search engine components that are popular these days. You can have a full text search in Postgres also with dictionaries and everything. You can, word vector index? I'm not sure I remember, but you can read about full text search, and if you need a search bar on your website, people deploy separate components, that might be really heavyweight, might be hard to maintain and stuff. You can just create a table and index specifically for full text search. And again, you have a full text search. So, a lot of these components, so what we mentioned queues, key value stores, full text search, and just typical data, typical database. We talked about how you have a lot of tools to scale just Postgres instance. So I want to ask people like, what would you prefer? You learn and master one tool, like Postgres, right? And you have all these ground and if you're like at small scale at the start, or you can go at a bigger scale, a lot bigger scale, right? With this, you can get a lot of users with this, and one database and you cover all this ground. Or would you prefer to deploy separate 5, 6, 10 components that are a little more specific? You need to relearn everything. You need to learn everything new about new component, and then they might be of variety in quality. They might have newer bugs and whatnot. They might not perform well in certain cases, not well-tested software. Like this to the test of time, right? This is rock solid. And you can have this today, right? So this is just some food for thought. Because, for instance, as far as I'm concerned, like new databases, what comes out, I'm usually not even interested. Because usually if they have like a few features that Postgres already has, I'm already impressed. But usually what I know, this common trend amongst these new components, like they put 90% of their budget to website design, and I tried playing around with some, I will not mention names, and you start testing these, And this is like garbage, right? Who would use this in production? It barely works. It's alpha software. The website looks nice, but I'm never running this in production. I don't want to waste my time, right? So, but to each his own, right? I'm just saying my company name is called Trivial Solutions. And again, this is, I think, a trivial solution that covers a lot of ground. Just when someone asks, I want a database, what do I use? I'll ask all these questions. Can we cover it from all this range of features that we have? And there are more I probably forgot. And if only then the answer is no, and certainly no, we can't use that because we're like super specific, we have to use this. Then yeah, there are very rare cases where I would prefer, where we would use something not Postgres, right? That is not Postgres, but other than that, this usually covers everything people need. So yeah, so this has been David from trivialsolutions.io. I'm signing out. Peace.